There is no doubt that signals in Angular will greatly and positively impact our Angular apps. Many teams already started adopting this reactive primitive, and even more are planning to do so. In both cases, when you start your migration to signals, you will encounter the following use case. You might have a signal, like in my case I have a search query signal, and you also might have some component input, like my users. Inside the computed function, I'm tracking the changes in the query signal, so every time the query string is changed, I will recompute the filtered users, leaving in the array only the ones whose name starts with the new search query string. In the browser, it looks like the following. I type in the search field characters like A and N, and only the user with the name Angela is displayed in the list. However, if at this time I will add a new user to the users array, he will not be displayed there, even though the new user name matches the search criteria. This is because our user's input is not reactive and changes in that array is ignored by the compute function. This is something we will be fixing in this video, and I will show you how to solve this problem if you use Angular before 17.1 and how to achieve the same thing using the brand new signal inputs. My name is Dmitry Rozhensky, and my mission is to help people to become advanced Angular developers who develop apps consciously, knowing what they are doing and how things are working. You can check out my YouTube channel as well as private courses to see which topics I covered already in the past, but today we will learn more about signal inputs. Before we dive into the topic, I would like to quickly mention an open source library, RxDB, which is the sponsor of today's video. Every modern browser has a built-in, local NoSQL database called IndexedDB. You can think of it as a local storage on steroids that supports a broader range of data types and different queries. RxDB is a database built on top of IndexedDB and exposes a reactive API based on observables, which is so familiar to every Angular developer. Using RxDB, you can locally store and reactively track the data changes across multiple tabs, and it cares about proper synchronization with your database on the server, which makes it a great choice for real-time apps. However, if your application loses the internet connection, it is not a problem because RxDB implements the offline-first approach, so your app will continue working and synchronize the data later once the connection is recovered. Besides that, it is easy to replicate databases across multiple devices and apps, and various plugins enable a wide range of supported environments like Node.js, Deno, Electron, React Native, Capacitor, and others. The core functionality is open sourced and free, so you can play with it already now. You will find all the links in the video description. And now let's get back to the main video topic. Let's quickly think about how we could fix this issue and make the user's input reactive if we use Angular before 17.1. Some of you could suggest turning the array we provide from the app component into a signal, and then provide the signal directly as an input value. Yes, after some adjustments it would work, but passing signals as an input value is considered to be an anti-pattern. I don't want to stop too much on it, just say that by doing so, you lose the unidirectional data flow and centralization of data changes, because child components can freely change the value of the signal, impacting the parent component. Even though you're gonna fix some of the issues by read-only signals, you still introduce a breaking change to your component API and force consumers of your component to use signals, which in the existing codebase might require additional refactoring efforts. A better way would be to transform input data to a signal inside the user list component. You could achieve it multiple ways, but one of the most popular would be using setters. So you could eventually have something like following. So here I introduce the private user's property, which is a simple signal, and the old input property I'm going to transform into a setter, which will be updating the user's signal with a new value each time the input value changes. To avoid naming conflict with the user signal, we can rename the setter and start its name with the underscore. This change, however, causes an error because we just changed the public component API. But we can simply fix it by using the aliasing feature and exposing the input as the old name without the underscore. The last but not least change is to adjust our callback inside the computed, because now user's property is signal, so we need to add parentheses. And fantastic, so now my code is reactive. So if I go to the browser, start typing AN, and then if I add a new user with the name Andy, I will immediately see him in the list, which was not happening before, if you remember. Since Angular 17.1, we can achieve the same thing much easier. Now you can simply remove this getter, and instead of signal right here, you can use a new function called input that comes from the Angular core, just like that. So here, there is no need for decorator anymore, just a simple function. Of course, you can have or not have the initial value, and if you don't have it, it might be undefined, so we would need to use the question mark right here. And last but not least, the corresponding input property must be public, because you will get a compilation error otherwise. This simple notation behaves absolutely the same way as the code before, because input function under the hood converts the value provided to this input as a signal. But what about other input features, like making input alias, transforming the data, or making the input required? So let's cover them one by one. To make an alias, you can use a config object that comes after the initial value. Here you can see a property alias where you can define a new value. For example, let's imagine that we want to expose it as a user input. But internally, we could rename the property to, for example, user list. And as you can see, everything perfectly works. But what about the data transformation? It is still possible. Just add a property transform in the configuration object and add that transform function as a value. I have already prepared a function that performs some transformation, and namely it concatenates the user's first and last name in a separate property called displayName and removes the first and last name from the original object. But once we apply this transform function, you can see that currently we have a compilation error. This is because the value type of my input signal no longer matches the one returned from the transform function. This is because when you define type like this, you automatically define the value type that can be written into this input and the value that we can read from it. So because after the transformation, we will be reading the value of modified user array, we have to reflect it in the input generic type accordingly and define the read value type as the first parameter in this generic type. So basically we say that we can receive a user array as an input value from some parent component, but inside the user list, we will use the value of type defined right here. However, if the transform function is properly typed, the input function can properly resolve types automatically from the transform function. I could just remove this generic type from here and let magic happen. So now you can see that types were perfectly resolved automatically, and I still see the hints where I have to adjust my code. So this is in the template here. And also I have to do it inside the computed callback and also replace the name property with the display name. Let's move forward and I will show you how to make the input required. To make a signal input required, you just type .required right here and simply remove the initial value, because the required value, suppose that the initial value would come from the parent component, right? So as simple as that. And in terms of features, this is everything what the input function can offer us, which is pretty much the same what the old input decorator does. However, the signal input has one quite significant difference compared to the input decorator, and it might impact the current logic of your component and also the way you test the component with signal inputs. You should remember that unlike regular inputs, the signal inputs are read-only, meaning that there is no API that allows you to change the signal value. The new value can be set up only by parents who provide value to this input, which is supposed to lead to the cleaner and easier to follow code according to the Angular team. But this leads us to another question, like how do we test components with input signals if inputs are read-only? Because before, to change the input value in the test, many developers were just assigning values directly to the component instance properties, which will not longer work with read-only signals input. And here you have two options. Option number one is to access the component ref from the component fixture and call the set input method that will properly set a new value for the input. Or you can use the test host strategy. It is when you wrap the component that is under the test with some additional component wrapper, and then you can pass input values from the test host component like it was in the real application. I cover both of these strategies in my dedicated course called Conscious Angular Testing that you can check out later following the link in the video description. Otherwise, in zone-based components, the input function behaves the same way as the old input decorator. The value of the input is still being updated during the change detection. It still calls the ng on changes lifecycle hook and so on. In the future, when signal-based components will be introduced, the changes will be more noticeable because, for example, the ng on changes lifecycle hook will be removed, and in order to track changes of your signal inputs, you would need to use the effect function, but we will discuss it in a separate video when the signal components are ready. But you can start preparing for the future already now by adopting these new input signals in your components to make the migration simpler in the future. However, I would not recommend migration for the big enterprise applications. In my opinion, it is too early right now, but if you have small application, you can already start to do it step by step. And if you watch this video until now and you feel uncomfortable, what are signals, effects and other computed functions, I have a dedicated video about that, so you can check it out following the link that appears somewhere here. Alright guys, thanks for watching this video until the end. I hope this video was useful, and if so, please share this video with your colleagues and friends, because it will help my channel to grow and get more traction. Also, follow me on my other social media where I regularly post different short tips and tricks about Angular, and yeah, don't forget to leave comments under this video, because I'm also curious what you think about these new Angular features and how you can apply them in your Angular apps. Otherwise, I wish you a productive week ahead, stay safe, and see you in the next video.